yours.
Check. All right. Good morning, ladies and gentlemen. I'm Baskoro Adi Pratomo, honored to serve as the chair of the 14th International Conference on Information and Communication Technology and System, ICTS 2023. So first of all, let me begin by expressing my heartfelt appreciation to the esteemed individuals, Professor Informatika as the head of the department, Professor ICTS Edi Purnama, the Dean of the Faculty of Intelligent Electrical and Informatics Technology, and Professor Muhammad Asari, Director of Institut Teknologi 10 November ITS Surabaya, for the willingness to accept our invitation and to open the ICTS 2023. I would also like to extend our heartfelt gratitude to our generous patrons, PT Pama Persada Nusantara, PT Wanadirga Nusantara, PT Petrokemia Gresik, PT Inixindo Surabaya, and Bank Syariah Indonesia. Your unwavering support has made this mesmerizing event possible, and we are deeply thankful. It is also right for me to extend our heartfelt gratitude to University Technology Malaysia, UTM, for their invaluable partnership, which has played a pivotal role in ensuring the success of this event. Last but certainly not least, I would like to express our sincere appreciation to IEEE Indonesia section for their invaluable co-partnership, which has played again a pivotal role in ensuring the success of this event. Furthermore, I want to express our appreciation to our esteemed keynote speakers, Professor Omer F. Rana, Professor Yuki Kadobayashi, and Professor Tohari Ahmad. Your willingness to share your knowledge with us is invaluable and greatly enriches this conference. A special acknowledgement goes to the diligent members of the ICTS 2023 Organizing and Scientific Committee. Your tireless efforts in organizing the intricate technical details of this conference have been truly commendable. For that, I can't thank you enough. Before I open ICTS 2023, I would like to mention some statistics from this year's conference. So this year we have received a remarkable total of 141 research papers from scholars around the world. Out of these, we have accepted 68 papers, posting an acceptance rate of 48.2%. This achievement underscores the high caliber of contribution we have received. As we embark on the intellectual journey at ICTS 2023, I extend a warm invitation to all of you to actively participate, engage in meaningful discussion, and contribute to the exchange of knowledge. Together, let us make this conference a resounding success. In conclusion, I wish to express my deepest gratitude to all the presenters, participants, and our dedicated staff and students for their invaluable contributions. Lastly, I extend an invitation to join us in the next edition of ICTS. Thank you very much for your attention, and I look forward to productive and enriching conference.
Thank you, Dr. Baskoro Adi, for the lovely speech.
Next, we would like to hear a few words from our Dean of Faculty of Intelligent Electrical and Informatics Technology, Professor ICTS Edi Purnama. To Professor ICTS Edi Purnama, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera buat kita semua. Good morning everyone. I'm Ketut Edi Purnama, the Dean of Intelligent of our faculty. I want to extend my gratitude to Professor Muhammad Asari, Director of ITS, for gracing us with his presence online virtually at ICTS 2023. I also want to express our sincere gratitude to the head of the Department of Informatics Department, Bu Justin, for her dedication and effort in making ICTS 2023 possible. And now I would like to extend my appreciation to our honorable keynote speakers who have graciously agreed to share their expertise with us. I saw here in the poster also Professor Omer F. Rana from Cardiff University. I hope is also present online right now. And Professor Yuki Kadobayashi from the Nara Institute of Science and Technology. Good morning, Prof. I ever visit your university in 2019? Yeah. And two years ago, yeah. 2 years ago with Bu Justin. And we also have a close relationship with Nara. Last month we have a regular weekly meeting with Prof. Sato from NICE also. And last but not least, Professor Tohari Ahmad, valued member of our own ITS community. He is expert in cyber security. Your willingness to impact our knowledge adds immense value to our conference, and we are truly honored to have you with us. Especially, I met my old friend, Bu Ovi from Petra. Yeah, we are in the same lab in, I think, in 1990, yeah. 1990, yeah. I think all of the students here are not born yet. Still become the butterfly in Balinese. And also, I'm happy because there are 10 students or lecturers from UTM. 10 students, 2 lecturers. Thank you for visiting us, and hope we have a close relationship in all department in ITS, especially in informatics department. Thank you very much. I hope you enjoy the hot weather in Surabaya. I think it's the same bit in Malaysia, yeah, except maybe the smoke maybe. And also, of course, the lecturer of informatics department would now present with uniform batik ITS. I wrongly read the letter, so I thought there is no batik uniform to be used this morning. Honorable colleagues, researchers, and guests, all of the attendee, on behalf of our staff and student of the Faculty of Electrics is the short of our faculty, short name of our faculty, I would like to welcome you in the 14th, Pak Baskoro, in the 14th International Conference on Information and Communication Technology and System, ICTS. I am honored to deliver this opening remark in this conference. The introduction of our faculty. Our faculty has or consists of 6 departments: electrical engineering, informatics, information system, and also computer engineering, biomedical engineering, and information technology. And this year we opened 3 new study programs: software engineering, and also artificial intelligence as a dedicated study program, yeah. And also digital innovation. And last year we opened telecommunication engineering. So in total, we have 10 study program in bachelor degrees. So I think the biggest number of study program in the faculty. We also have 4,310 students spread out in bachelor degree, 3,600, 3 master program 422. Good morning, Prof. Supono Janari and Prof. Handayani. And also we have 3 study program in informatics, electrical engineering, and also information system. We have 178 lecturers, qualified lecturers, of course, and we have a double degree in with many study program abroad. I think we have also with UTM. Ya Pak Ari ya, with UTM. Okay. And also we have in artificial intelligence, we have a supercomputer, DGX A100. So this supercomputer, we proud that we can establish this supercomputer not given by our university, actually, not given by our government, but we collect the money from the 6 department and we buy those supercomputer machine. So very welcome if you can use this supercomputer, of course, in terms of collaboration with our researcher. And I know that Prof. Rianarto and his team using this machine very much because the work need high speed and also high memory to process the work. And also we open for international and national collaboration, including with UTM, of course. Ladies and gentlemen, our faculty electives has a tagline: bring humanized intelligent technology for society. Not only aim to become a reference for education and research excellence, but also to contribute to the humanity and society. And the motto of our faculty is in line, I think, with the theme of this seminar: securing the future one bite at a time. So that's also implemented in the scope of this seminar, and very in line with research and community services that has been carried out by researcher from our faculty, especially from the informatics department. For example, our faculty in the COVID period, we create a robot Raisa who deliver goods and also medicine to the patient, operated remotely by the medical staff. So reducing the interaction between patient and also the doctor. And also we develop a robot to lift the patient, and also remote what do you call, infusion system. Yeah. So ladies and gentlemen, our faculty welcome and encourage such collaboration, which we believe also can also support us to achieve, as mentioned in the theme of this conference. So honorable speaker and participant, the 14th ICTS has a broad scope, as mentioned by Mr. Baskoro: biomedical application, big data, computer network and architecture, content-based multimedia retrieval, digital forensic, distributed system, and so on. And this conference provide a golden opportunity to meet the people behind our program, as well as to foster research collaboration. Therefore, I hope more idea will be created and initiated through this conference. So I would like to congratulate all of the participants. I look forward to witnessing the fruitful interaction and collaboration that will unfold during this remarkable conference. Many thanks to keynote speaker and also the sponsors as IEEE and private sector. And lastly, I would like to express my great thanks to the committee who had tried hard to hold this seminar. General Chair Pak Baskoro Adi Pratomo and Technical Program Committee Dr. Ratih Nur Esti Anggraini. So thank you. Wassalamualaikum warahmatullahi wabarakatuh.
cybersecurity enthusiasts here seem really looking forward to see what our next event really is. What's next here?
Ladies and gentlemen, now is the time for our main event, which will be the presentations from our remarkable keynote speakers. The first presentation will be Security and Data Privacy Challenges for the Edge Cloud Continuum from Professor Omer F. Rana. Professor Omer Rana advances in performance engineering and previously has led the Complex System Research Group. His research interests lie in between intelligent systems and high-performance distributed computing. Particularly, he is interested in understanding how intelligent techniques could be used to support resource management in distributed systems and the use of their technique in various applications area.
Ladies and gentlemen, all of the presentations for the main event will be moderated by Dr. Ari Masardi, one of the informatics lecturers. Dr. Ari.
Hey, good morning everyone. Assalamualaikum warahmatullahi wabarakatuh. Yep. Your Honors, Professor Renato Sarno, Professor Iketut Edi Purnama, and other guests from UTM, Professor Informatika as the head of department, Dr. Baskoro as the chairman of the ICTS 2023, and other colleagues of informatics department. Today we will have the first keynote speaker presented by Professor Omar F. Rana from the Cardiff University in United Kingdom. The topic of this first keynote speaker is security and data privacy challenges for the Edge Cloud Continuum. We will be listening to the first keynote speaker for about 40 minutes, and then we'll be having the question and answer session for 20 minutes. So without further ado, I would like to invite Professor Omar F. Rana to present the first keynote speaker. Yeah, all video, yeah. That'll be, yeah.
Assalamu alaikum. So this is Omar.
Yeah,
I'm online right now, so
okay.
I'll be available for questions after the video.
Okay. So, yeah. So, while waiting for the technical issues to be solved, Cardiff University is one of the top.
Thank you very much for inviting me to give this talk at the.
Sit down. Yeah, as I said before, Cardiff University is one of the top universities in Europe, yeah, particularly in United Kingdom. So it produces a lot of scientists and practitioners throughout the world. And then we are very honored to have Professor Omar F. Rana here. One of the graduates is Dr. Baskoro Adi Pratomo, and another one is Bu Nurul. Yeah, Bu Nurul Fajri is still in Cardiff University to pursue her PhD study. Well, hopefully she will be successful for her study in there and then come back to Indonesia to join us again and to develop my informatics department. Is it set up already, or was it waiting for a few seconds? Yeah. Okay, it's on now. So, okay.
14th Indonesia Conference on Information Communication Technologies and System.
Okay.
The title of this talk is Security and Data Privacy Challenges for the Edge Cloud Continuum. I'm grateful to Dr. Adi Pratomo for inviting me for this presentation. You can see my details at the bottom, my email address, and if you like what you hear, you can follow me on Twitter. if you look at different perspectives on data privacy, often data privacy is a balance of competing interests. On one hand, we really want to make data available for use to carry out a variety of analysis, whether this is in medical research or healthcare and advertising and education and so on. And most importantly, the reason we want to make data available is to enable algorithmic auditing. So we want to know, for example, how specific algorithms are making their decisions. This is particularly relevant, for example, in machine learning today, where fairness and bias play an important part in developing our machine learning models. Alternatively, on the other hand, when we make such data available, we also need to protect the privacy of an individual whose data we are sharing. So there's issues around personal value, privacy, and respect for individuals. And there's a number of regulations that are available today that focus on privacy. So we have FERPA, HIPAA, and GDPR. So FERPA is very much about protecting student records and ensuring that student consent is taken when their records are shared. HIPAA, on the other hand, applies to healthcare, and GDPR, the General Data Protection Regulation, is a European regulation that is focused on protecting consumer data when consumers are connected to businesses. So essentially, we want to be able to protect individuals, but also make the data available. And as a consequence, this creates an interesting challenge, and how do we do that effectively? So one way that people often discuss today is that rather than share the data of individuals, what we do is we share the model, we share the learned model. However, this also introduces a number of challenges. So people have observed, for example, things like model inversion and membership inference attacks. And therefore, a variety of libraries are also available, such as TensorFlow Federated with differential privacy, as you can see the link towards the bottom of this slide. And TensorFlow Federated differential privacy supports clipping and noising as two different functions that can be added in order to prevent revealing of personal information as part of the model building process. However, we are still at a very early stage in this process, and still lots needs to be done in order to be able to facilitate these two competing interests in some way, i.e. making data available while still protecting individual privacy. So given this context, there are three research questions that I really wanted to focus on in this talk. The first question is that as cloud computing becomes a dominant mode of electronic service delivery today, so virtually all our Internet of Things and edge computing environments are communicating with a back-end cloud system which is used to store the data and also to process this data in some way. So the question we ask is that are we sacrificing privacy for access to online services, particularly to support issues such as business continuity? Secondly, if we are going to make use of a cloud platform to process and manage our data, can we create an auditable cloud computing infrastructure? So that means that can the activities that the cloud computing infrastructure is carrying out on our data, can we somehow identify what these are and hold cloud computing providers accountable for what they do? This again introduces a challenge in the sense that in order to support auditability, we need to record or monitor what the cloud computing infrastructure is doing. And therefore, there is a trade-off between recording too much data, right, which is going to have an impact on the performance of the cloud, versus transparency, that is understanding how user data is handled and managed. This again is a fine line in terms of understanding what should be recorded and at what level of granularity. So that's the second challenge. And a third question we ask is that increasingly clouds and AI systems are being used together. So many services that are hosted on cloud computing infrastructure also make use of artificial intelligence and machine learning. So the question that underpins this aspect is that how does this change the way we design and develop our cloud services if both AI and cloud are being used together? So what this means, for example, in the privacy and cybersecurity context is that often when we use AI services, we often do not know how the AI services will make use of our data. For example, it's very hard to explain what the AI algorithms are doing. So how does a user who gives their data to a cloud provider to perform analysis, how can the cloud provider make sure that the analysis that is being carried out is taking account of consent that the user has provided, right? So these are the three major questions. I don't feel there is an answer to these, but I will identify a bunch of research projects we're carrying out at Cardiff which attempt to look at these three questions from different perspectives. And of course, I'm happy to discuss these with colleagues who are listening to this talk online. So let's start with the first example. So vehicular systems or vehicles are getting more and more complex. They have a variety of sensors that are within them. We can have engine sensors. So there's a whole variety of sensors that can manage the operation of the vehicle. So this includes transmission sensors, radiator airflow sensors, power brake assists, and so on. But there are also sensors within the vehicle that are helping the driver, the user of the vehicle, operate the vehicle in a more effective way. So seat positioning, power mirrors, etc. So these are all examples of other sensors. These sensors are all connected within the vehicle through an internal network. So these are controller area network that can operate at different bit rates and speeds, as you can see in the table. So on one hand, we have the core sensors, such as engine oil level and pressure, coolant temperature, air intake, airflow and temperature, engine throttle positions, and so on. But with the type of vehicles, and as vehicles change, for example, in electric vehicles, we can have another additional variety of sensors. So you can have battery state of charge, battery characterization, such as voltage, temperature, cycling, but also battery management systems that are within the vehicle that identify how the cells or fuel cells within the vehicle are operating over time. So all of these are different sensors, and capturing the data from these sensors introduces another potential attack surface that we need to manage within a vehicle. The firmware, the software that manages the data from these sensors, needs to be updated. So currently, often what happens is when you take your vehicle to a mechanic, the mechanic will connect a computer to the OBD port, the onboard diagnostic port, to look at any error messages or the current version of the firmware that you're using. However, the concept of over-the-air updates is to do these software updates or firmware refresh over the internet. So the idea is that this improves longevity and performance of the vehicle, but also makes it more secure, potentially because you're trying to fix any flaws in the firmware that the vehicle is using. Of course, this does not just apply to vehicles, it can also be used for a variety of other devices within our home, Internet of Things devices that we use within our home. So for example, here's a paper, you can see a reference here towards the bottom, which describes how learned machine learning models can be pulled in over a web server onto IoT devices. So these Internet of Things devices make use of these machine learning models. But these machine learning models can then be updated over time as new algorithms are being developed. So we can have object classification, face ID and recognition, people counting, and so on. And they can also make use of pre-trained models using the algorithms that are mentioned in that box on the right. So these are Tiny YOLO, ResNet, and so on. So the device will go and access these models, online models. They will then put them on the device itself. And these devices make use of a variety of IoT hardware, which can include microcontrollers, for example, small FPGAs, and other type of processing engines. And you can see a list of these hardware components that make up these IoT devices. So the key message here is that these edge Internet of Things devices can include firmware that can be dynamically updated. That firmware can also utilize machine learning models. And this again opens up the potential attack surface that are associated with these devices. Another example that I will look at is this industrial environment or a factory environment. So if I have a production line with a number of actuators, these are robots, for example, that can manipulate things that go on this production line. These actuators are connected to a programmable logic controller, a PLC, that also can communicate with a gateway node to other sensing devices which are within the vicinity of the actuator. So F, for example, the F labels here indicate potential sensors like cameras that can monitor how the production line is doing and how the actuator can carry out some action on the production line itself. The PLC is then connected using a back-end system to a cloud environment. So you can see here, it can go through a firewall and a corporate network and connect to a back-end cloud environment. So between the actuator and the PLC itself, we can have a number of data comms protocols, such as Modbus, TCP, DNP3, the CAN, the control area network, and so on. And increasingly, these edge devices are then connected to actuation environments that are cloud hosted, right? So the cloud again becomes an important part that connects and manages the characteristics of these industrial control systems. You can see here a number of protocols that make use of this in different kind of contexts. So we can have industrial Ethernet, such as EtherCAT and Ethernet IP, to field bus interfaces. You can see the companies and the organizations that have developed these, and also the network topologies and the range over which these networks can operate. So we have a paper that which surveys some of these protocols and explains the vulnerabilities that are available within these protocols. So the boundary, therefore, between the physical world and the cyber world is changing, right? So here we have a cyber domain which is facilitated by the PLC connected to the actuation environment, and the physical world which is actually manipulating the physical object. So the boundary between the IT and operational technology networks is fading, and establishing a demilitarized zone can also be prone to attacks. Consequently, what happens today is that you only allow essential access to software user to limit the types of attack surface that is available between the cyber and the physical domain. It provides easy to analyze systems, and role-based access control has often been used in the past to achieve this. A variety of other techniques are also available to monitor, for example, what happens within these cyber-physical systems. As edge devices are targeted, the attacker will try to maximize the damage by disrupting the behavior of the actuator. And after a breach has happened, for example, an adversary might want to fake sensor readings or disrupt the behavior of these actuators. So all of these are the type of attacks that you would see in this kind of context. So this has been considered in the European context, in the European and French context, in the sense that many cloud providers which are being used within Europe today are US providers. They're often offshore providers, and they constitute 69% of the EU market. So what the French and European governments are attempting to do is to consider this concept that in a cloud-first strategy, you should utilize service providers that have a presence in France. So you have the OVH Cloud, Outscale, OO These are examples of cloud providers which are physically hosted within France. They can also include specialist providers, as mentioned here, which provides secure storage, for example. But that storage then needs to conform to regulations that are also provided by local government, in this case the French government. So Secnum Cloud is an initiative within Europe that identifies how cloud services that are hosted within a European context can conform to European regulations. And many of these cloud providers can also integrate with more commercially available systems, such as Amazon Web Services and EC2. So 3DS Outscale is a company that deploys a model in which all the processing carried out on the data needs to be carried out on the national territory of France. So that means it must be under French law and in application of French laws and standards. So this is an interesting development because it says that any data coming out from users within a certain country needs to have cloud services which are also hosted within that country, so that they can utilize legal regulation that is provided within the context of that country. So Secnum Cloud, as I mentioned, is a trusted cloud initiative supported through the French National Agency for the Security of Information Systems. And it's a standard now used for vital and essential service providers that make use of cloud services. So the key idea here is that any organization that offers cloud services must require a security visa in order to operate within that particular country, and the operations of the cloud provider has to be audited by a number of approved laboratories within France. We can see some references there. So trusted cloud services should have electronic certification, incident detection, timestamping, and so on. And there's a whole bunch of legislation that says what administrators and orchestration systems must do in order to facilitate the deployment of these clouds. So cloud provision therefore becomes the weakest link, right? So understanding, for example, how we can consider cloud security, especially when we connect to IoT and other devices, becomes key. So one aspect that we looked at in this context is to identify how the General Data Protection Regulation applies to cloud and IoT services. And the first thing we consider is this concept that often when consumers are selecting a cloud provider of interest, they're often driven by the price. For example, at what price do cloud providers make their services available? So, for example, if you access a virtual machine or a container framework, consumers may often be interested in what is the price per unit of time that that virtual machine or container framework is available. However, we wanted to define the concept of a service level agreement that also takes security into account. So we define these things as security service level agreements, and we can use these as a way to audit cloud providers based on security breach information and approaches that are being used by the provider to protect user information. So we come up with this model which is used as a mechanism to assess the likelihood of having a data breach, for example, within a cloud system. We can see a paper at the bottom that explains this in a little bit more detail. If G references a point where you look at whether a data breach has happened within a cloud provider, the data breach could happen due to a number of criteria. P1, for example, here, P1 to P12, identify the different locations on a cloud hosting environment where data breach might happen, right? It could be an active or passive data breach. It could be during data production or transmission or storage. It could be after data deletion, right? So a cloud provider deletes your data but does not do it, effectively, in the sense that somebody can still read a trail of the data although it has been deleted from disk, and so on, right? So P1 to P12 identifies where the data breach could happen, and A1 to A16 here refers to activities that a cloud provider can carry out, right, to limit this data breach, right? So you can do data encryption, you can do storage encryption, you can implement access control, right? So for each of the A1 to A16 activities, you can provide these as different levels of complexity, and I'll come to this in a minute. So what this tree-based structure identifies is a way to audit a cloud provider on how effectively it is demonstrating or utilizing a certain set of security credentials to protect the user's data on the cloud. So we can define, therefore, a bunch of what we call data breach scenarios. Right? The first scenario refers to A1 and A2. So A1 refers to data in non-production mode, and A2 is data sanitization, which is equivalent to taking the data and anonymizing it in some way. So what we say is that each of these security breaches has weights, W1 to W3 in this case, or S1, which indicates, for example, how important it is for a user to carry out those operations on their data. And we can therefore define a security policy, which we refer to P1 to P8, which identifies how you take these different credentials of what the cloud does and weight it according to importance that users associate with them. And for each of these leaf nodes, A1 to A16, we can associate a difficulty level. For example, what that means is that if a cloud provider, for example, is supporting anonymization, what are the type of algorithms that they would use, for example, to support anonymization? So, for example, in A2, so the type of algorithm that the provider is using can be used as an indicator of how complex it would be for an attacker to break down that anonymization approach, for example. Right. So we have this table which looks at the grade from 1 to 5 of the level of complexity associated for each of these A1 to A16 levels. And you can see here that for A2, you can either use k-anonymity or you can use differential privacy. Differential privacy is potentially computationally more expensive, but it provides you a higher grade of anonymization than, say, some of the other techniques. Right? So this is a table that can be used to assess the complexity of A1 to A14 offered by a provider, right, which is this table at the bottom of this slide. And what we can do is we can take both of these and then rank cloud service providers based on how well they are doing across each of these different data breach scenarios. Right, so what this does is it's a mechanism to compare cloud providers. It just says that, cloud providers has offered the best capability they have. It doesn't mean that a data breach will not happen, but it just assesses the likelihood of a data breach given what the cloud provider is offering. And consequently, we can create these risk probabilities associated with how effective a cloud provider is at managing these data breaches. And we can therefore compare these. So you can see for scenarios S1 to S8, we can then compare these cloud providers, which are identified here. So CSP1, for example, offers less potential protection than perhaps CSP3 or CSP4 and CSP5 for data breach 1 or data breach scenario 1, right? So this is how we can audit a provider for each of these different breach scenarios, right? And create a risk probability when only one attribute is considered within the leaf node. Okay, so that's just one way we can use as a way to compare cloud providers. A project that we built on top of this work was looking at this concept of how multiple cloud providers are involved in a data provision. So here's one example of how this would work. So when a user is connected to a website, for example here, a photo sharing website, behind the photo sharing website, there may be a variety of other cloud service providers. So for example, you might use Amazon Web Services to store your data, you might have advertising services, you might have Azure Analytics, for example, to analyze your data. So what this project called PACE was looking at is that the user is often connected to a website, but the user may not know about all the other services, right, that this website is making use of. Because the user just has visibility into this service provider, the user will not be able to see the ecosystem of services that sit behind that website or behind that cloud provider. So the idea is the way cloud services work today is we have an ecosystem consisting of multiple providers who are often invisible from the user. Right, so each of these providers, like Amazon Web Services and Azure Analytics, carries out operations on the user, but the user is often unaware of what events are carried out on their data. These cloud providers may be located in different parts of the world, and cloud providers may utilize different availability zones as a way to give reliability to the user. So what this project was really focusing on was to identify how the events that are carried out by these different providers on user data and how we can make these events visible to the user. So even though they're not able to see AWS and Azure, but they will be able to see what operations these service providers carry out on the data hosted on that website. And we wanted to make this transparent to the user. This project included a number of universities. It was led by Cardiff, but UCL and Newcastle were involved. And we had a number of industry partners also included in this. So the way this worked is that we added this privacy and access management layer. So the cloud providers had a service management layer that they would normally provide, such as managing quality of service or configuring service providers hosted on a cloud platform. But we added this layer of container management, where the containers had an event management mechanism, whereby every time a cloud provider accessed that data within a container, that event would be logged in a blockchain network. And by auditing the blockchain, we would be able to see who accessed the user data at any one time. Right? So this is the general idea of this work. So the idea would be that a user is interested in GDPR and understanding, for example, who has accessed the data of that user. So the way this would work is that when a user shares their data within a container, that container also includes a GDPR monitoring agent. The agent would monitor all the activities that are recorded on the user data. These activities would be contained in a GDPR event log, and we would then go and look at and process the event log to identify who had accessed your data at any one time. If you try to record too much information in the event log would become very large and very hard to manage. So what we did instead is that the recording agent, right, the GDPR compliance agent, would only record 4 types of operations. Right? These are the operations that would be relevant to verify whether GDPR compliance is happening or not. So we'd have the read operation, the write operation, transfer and profile, and provided any cloud provider tried to run these operations on the user data, the user will be informed of this through monitoring this through an event log, right? So, and these operations that would be carried out on the user data, there would be a transaction created every time the interaction happens, and this transaction would be shared within a blockchain network. And by monitoring the blockchain network and running processes on the blockchain network, we could then verify whether GDPR compliance has been violated. Right, so here's an example. So if you have a user who owns the data and you want to make your data available on a hosting platform such as Cloud4You. So Cloud4You will have the user data, but the Cloud4You will also include a GDPR manager, so that if a number of service providers such as FriendFace or Frugal or Western Union or PayPal try to access this data on Cloud4You, then there would be a data, this would act as a data controller and would log this data within a backend blockchain network, right, which is indicated here. And the type of monitoring information you have was essentially this. So it would be access, who has access to read your data, whether somebody's tried to transfer your data, somebody's trying to profile your data, and so on. So these are the operations that this container will record. And then, as part of the verification process for each of these operation types, you would have a verification operation that could then be run on that service that is being run on the cloud platform. So by having an operation on the container and an equivalent verify operation, these would go hand in hand as a way to do validation or checking on what type of operation has been carried out on your data. So we actually implemented this using a backend blockchain network using Ethereum and Solidity. And you can see those 2 papers at the bottom that explains the architecture and the way the implementation was carried out. So these 4 operations conform to these GDPR compliance rules, right? So the read operation was that you serve it with sensitive data. So if you're not reading sensitive data, then GDPR would not hold, right? It's not just any data, it's primarily sensitive personal data, such as service support encryption or authentication access. So for example, if you do not support encryption, that would also violate GDPR compliance. So these are the type of questions that we derived from the legal regulation, and we could then verify these based on the logs that were recorded by these GDPR compliance agents. And these are a summary of the type of things that you would record. So encryption would be important for all operations, whether user consent had been obtained, how long you were going to write the data for, so there was a storage time, or was the data erased? So for example, if somebody requested the data to be erased, was the data actually erased, and so on. So all of these are the type of operations that would be checked for read, write, transfer, and profiling. And these were then mapped into a set of smart contracts, which were then implemented using Solidity, and they could be validated on the data recorded by the user. We tried to then carry out the performance penalty of carrying out this type of compliance checking. And in order to do this, we looked at 3 different types of benchmarks, right, that were available within our system. The first one was when we only had 2 services. So we had a user and we had an online pharmacy. In the second case, we had 4 services, 4 cloud-hosted services, or 4 different cloud providers. And in the third, we had 6 cloud providers. So what you see here at the bottom is the 3 service packages, the number of actors, the number of cloud providers involved, how many operations were carried out by each cloud provider, and this is the number of the costs in terms of the V costs, which is essentially the cost when we try to use a blockchain as a way to carry out this kind of analysis. So what we really wanted to do here was to identify the performance overhead of recording this kind of information in a blockchain, and how the performance overhead would impact the normal operation, right, if this type of verification was not being used, right? So it's the injected load within our system. So here we have these three service packs, SP1, SP2, and SP3. SP1 is here, SP2 here, and SP3 here. So what you want to see is the percentage CPU overhead, right, of utilizing our approach. So here, for example, what we can say is that if you only had two services, you would have an overhead of about a maximum of 25% on CPU compared to your normal operation, right? Whereas if you use service packs 2 and 3, which are primarily looking at 4 and 6 providers, you would have about a maximum of 40%, just over 40% of overhead, right? Depending on the events that are being recorded. So these values on the x-axis are different type of events like read event, write event, and so on that are being carried out on the data. And then the performance analysis here at the bottom is measuring the memory overhead, right? So how much additional information do you need to record, right, as a way to ensure that you can do compliance checking. So here we demonstrate that you have about 3,550 megabytes which are being used for Service Pack 3, right, as a way to do the additional compliance check compared to what would be the normal data that you would need to record. So of course you can change the memory requirement by limiting the number of read-write events that you record depending on what kind of compliance you're interested in. Right, so this is a kind of overhead profile that we observed for our system. And then we also looked at two other metrics, which is latency and throughput. So latency measures the time between an event being recorded and it being submitted to the blockchain, it being added to the blockchain. So it's a time in millisecond between making a submission that an event had occurred and then completing the recording of this in a blockchain or logging it in a blockchain. So this time varied between about 52 to 63 milliseconds. Right, so you can see here the average latency. It starts off high, for example, as a number of requests. This is the time when you have a cold start time, when you start connecting into the blockchain network, and then it eventually converges, right, to a value that you can see here, anything between about 52 or 50 milliseconds and above, between this range here. And so here we have 13,000 requests, right, coming into our blockchain system. And the other value we observe is the throughput, that is how many transactions that you can have for recording events within this blockchain network. So again, we see a convergence. So they start off, the throughput starts slow, but eventually it converges to anything between 7.7 to 9.6 transactions per second. So that's again a way to measure the overhead of utilizing this blockchain to record these additional events. And this paper at the bottom explains how this measurement was done for the scenarios that we considered. So that's just one example of how we can combine a blockchain network that can be used to record events from what happens on a cloud provider, and then to audit these events to identify whether a cloud provider was conforming to a privacy legislation or not, right? So this kind of legislation checking and doing it in such a way that you minimize the overhead of doing this, right, is key to getting this more widely adopted. And the final part of this talk will look at privacy-aware design of IoT services, for example. Whereas what I've discussed so far is where we're looking at privacy once your service has been deployed on a cloud platform. What this last part looks at is what happens if you try to design privacy straight at design time. What do you consider privacy as straight at design time when you're trying to develop and design your Internet of Things service? So increasing privacy awareness is also important for software engineers, right? It's not just important when you deploy your stuff on a cloud, but you should take privacy into account at the time of creation of your software, right? So we call these privacy patents for IoT devices. So here, this paper at the bottom looks at the kind of requirements that you would have when you try to develop a IoT application and where privacy needs to be taken into account. So here the idea is that how can we work with developers, lawyers, and other privacy professionals to understand what requirements they have when they try to develop privacy-aware IoT applications. So this survey was carried out working with a variety of stakeholders, from software developers to privacy lawyers and users, as a way to understand, for example, what privacy needs they would have when designing this application. And the question was that by taking this survey, can we then create a software tool that allows such privacy requirements to be taken into consideration right at the design time? So for example, you could think of it that when you're designing an application, right, can this software tool tell you what privacy requirements you need to take into account, right, while you're building your application? So in this, we compared two different type of security and privacy tools. We have Stride and Linden. These are two very widely used tools, and they consider a set of properties that are available within these IoT applications, from integrity, non-repudiation, confidentiality, and the type of threats, right, that they would be relevant for this type of property. You can see the two methodologies at the bottom, which are very widely used lifecycle development tools for security. And so in this kind of work, we considered both of these approaches and how we could extend them and somehow utilize them for the development of these IoT applications. So this is the idea. So if you have a user and a person who is considering security, so what are the privacy by design patterns that you should apply if the system collects data for a user, right? So what this Oracle, the built-in software tool, comes up with, it looks at location granularity privacy patterns that you need to fulfill while you're building this application. So we have a personal assistant which works with a developer to identify the types of considerations that they should take into account when they're building this application. So it has about 81 competence questions which are recorded as Sparkle queries, and it takes a security policy and converts it into this ontology design pattern that can then be used by a developer when they're building this application. And this is the approach. So we carried out a bunch of workshops where competency questions were identified. These were then filtered, and eventually an ontology was created as a way to build this tool that could then be used by application developers. And this is called the Parrot ontology. And you can see more details about the Parrot ontology here in this paper, which is primarily a way to help users consider security at the design time. And these are so they're depending on the type of application you have. For example, healthcare systems or fitness tracking, a number of competence questions were included, which should be taken into account, for example, when you're building a smart home system or a drone delivery system and so on. And these are the type of things. So the privacy requirements would relate to data collection, the type of devices on which the data was carried out, the type of process, for example, that was involved, where the data storage was happening. Was it locally on your local system, or was it happening on the cloud? So depending on what the developer was considering, right, we would consider the relevant competency questions that should be taken on board. And then we have this Sparkle queries that can then be used as a way to capture these patterns while the user is developing this application in real time. And so this is a privacy by design tool for developing IoT applications. And finally, I will end with this work that is taking place with some of our colleagues in Imperial. So here what happens is, so this is a paper from 2019 which describes a number of IoT devices which sit within two different labs. So there's a UK lab and a US lab. And there's a number of IoT applications. These are audio, cameras, home automation systems, television, smart apps, and so on. So what this study was trying to do is, when an IoT device such as a camera records some data, where is this data sent, right? So for example here, data coming in from a UK lab using cameras was sent primarily to the provider, the US provider, but it was also sent to other destinations. So it was sent to China, Hong Kong, Korea, the EU, and so on. So although the data provider indicated that it should be sent to the US, but that's where the core cloud hosting provider was, it was also sent to other destinations. So what this study was trying to identify is that how does traffic get propagated from an IoT device to a destination you might not have thought it would go to. So during these experiments, devices in the US were contacted Netflix.com, a variety of other providers in Korea and China, and Facebook.com, and UK devices were communicating with a variety of other providers, often advertising providers, which a user was often not aware was happening. Right? So again, the question here is that can these interactions that happen between IoT devices and external providers be made more visible to a user? And this is more recent work from the same group. This is called the IoT RIM, where again, depending on the type of cameras or home automation systems or hubs that are being used, what this tells you is the locations to which the data from these devices is being propagated and forwarded. And can you somehow try to block certain sets of locations, and the user will have more control, right, of how to do this blocking for these type of IoT devices. And in Cardiff, we've also built a number of other prototypes. So this is being developed by a student working with my colleague Charit Pereira. So this is a device that sits within your home. So you can think of it like home furniture. And the device has different faces that you can observe here. You can think of as a piece of furniture that sits on your table. And what it can show you is where are the devices within your home, like home Alexa, Alexa speakers, or other type of IoT devices. Where are they sending their data? What it shows you is whether a device is currently active. So if you have, whether the device has a microphone turned on, you might not be aware that the device has a microphone turned on. Whether it's sending audio data, whether it's sending data to different locations, and then it also lights up these different LEDs telling you where the data is going at any given time. So what you can do is you can put this device in your home and just see, for example, how IoT devices within your home are sharing information without you even being aware that this is going on. This kind of device is really interesting because it helps people within a home to raise discussion about, you know, how your data is being shared without you even knowing that this happens. So GDPR requires clear affirmative action by the data subject with details about the agreement, identifying the controller, the purpose of data processing, and the right to withdraw consent at any one time. The question is that in many cloud-hosted services, we rarely know whether this is actually happening. So data subjects can withdraw their consent and require erasure of the data, something called the right to be forgotten. And this remains a challenge in GDPR. So over COVID-19, for example, when all of us were connected to online services, many organizations were sacrificing data privacy. GDPR becomes even more significant with Internet of Things and edge computing because users are often unaware that their data is being transferred to locations. So having this recording mechanism, which does not impinge performance, right, that's pretty important, becomes pretty crucial for supporting this kind of data management. Thank you very much.
Thank you, Professor Omar, for the insightful presentation. And now it is time for the Q&A session. Please raise your hand for the audience to submit your question or use the online platform to on the Zoom meeting. Okay, let us make the most of this opportunity to explore further about the security and data privacy on the edge cloud continuum. All right, I will start collecting the question from the audience. Perhaps one or two questions from the floor. I think anyone. Or maybe you can check the online platform. Is there any questions in there? Already? Yeah, I think there's some. Yeah? Okay. Anyone? Right. Professor Omar, I think I have two questions that I need to raise regarding this topic. The first question is, it is about the how can we implement the data security in edge cloud continuum, considering that the edge devices are normally limited in resource capacity, And the second question is, it is about the classical trade-off between security and convenience of the user, that if we want to improve the security, then it will affect the convenience of the user. So how far can the concept of the security in edge cloud continuum can be implemented that influences the user convenience in using the system? So I think those two questions. Did you get my questions, Professor?
Yes, I did. So first, thank you for the opportunity to present this event. So I'll take your second question first. I think convenience is an interesting question, right? So I think the understanding, what a user would lose if they lost access to their information. I think this concept of, understanding, making the impact of the breach more visible to a user, I think is important. Many companies, for example, lose a significant amount of money as a consequence of data breaches. And I think making that more visible is very important. I think the second question is that in many cloud systems today, many cloud hosted platforms, security is often what we call under a shared responsibility. So shared responsibility means that, you might have a cloud provider who gives you the best type of security. They might support encryption. They might support, data deletion automatically, preventing, logs from being shared across VM instances. But ultimately, the cloud provider should not be the only entity or actor involved in supporting privacy and data security. The user also has a role. And I think we need to make that very visible to the user. So for example, if you might record the best password, but if the user compromises the password on their end, it's not the cloud provider's fault. So I think in many of these hosted infrastructures like cloud, the shared responsibility model really needs to be propagated and shared. In terms of the security for edge devices, I think the edge devices are changing in their complexity. So currently people use microcontrollers and very limited capacity IoT devices. In the future, we are moving toward the view of edge, where we use NVIDIA, AMD, and accelerator devices on the edge. So what we can do at the edge, in fact, will change over time. So currently, the way this works is that often these edge or IoT devices communicate to a gateway node, your first hop gateway, which could be a first hop router or first hop switch. And often the security credentials are implemented through that first hop device and not directly on the IoT device itself, if they're constrained in their capacity. So you could think of, therefore, the edge is the first hop gateway that your IoT device connects to, which then encrypts the data or supports other type of security capability. So that's really the way it works today.
Yeah, thank you, Professor Amar. And I think for the first question about the capability of the devices, I think the devices has been improved a lot as recently. So it's not the one that we used a long time ago. So there are some advances in the newest release devices. So it will be capable of handling those kind of encryption algorithm, as well as maintaining the performance of network as well, or the data transmission as well. And then the second question was about the convenience versus the security. I think the risk of losing data is much more severe than the convenience that will be sacrificed in terms of maintaining the security. Okay, thank you for the answer, Professor. I think there's one question from Dr. Baskoro Adi Pratomo. I think you know him already. So the time is yours, Dr. Baskoro. Yeah. Microphone, please.
Hello, Omar. Good morning.
Hi, good morning.
Okay, I have a question about the topic. So you explained. I was very interested with the box that you showed us on the later slides. I was just wondering if there's any similar research that you've done, or maybe any similar research from other researchers that have done about analyzing the compliance of privacy in mobile applications, because we have a lot of mobile applications out there, and sometimes it's hard to know what they're actually sending to the servers or to the third parties. Yeah, that's probably my question. Thank you.
Yeah, no, that's very true. So I think that we have to. So going back to the previous question that was asked, the privacy versus convenience question. I think if you're using an online service using a mobile device, and the service you're using is free, then your data is what you're paying for that service through, right? So I think today the major monetary model of the internet is through advertising. And advertisers get access to all the data that we ship out to them in a variety of different ways. And there are a whole bunch of advertising networks, right, that really drive the internet today, from affiliate networks. And I think that IoT devices provide another entry into the advertising network. Of course, there are legislation. So, for example, I'm not sure, the EU, the European Union, has this new thing called the AI Act, which is trying to understand how AI services can utilize IoT and edge devices. But I guess the question comes back to that, if you're using free services on IoT devices, then advertisers are constantly getting your data. And you should be aware of that. I think it's raising the awareness. And I think that there are groups in Asia, such as Cloud Asia, which has a presence in Singapore. I think it also has presence in Indonesia. There's Cloud Security Alliance and so on, which are looking at some of these challenges. But certainly a very important challenge, exactly as you say.
Right, Dr. Bhaskar, do you have any further follow-up for this question? Okay, I think thank you, Professor Omar, for your presentation today in this ICTS event. I think we can close in the first session of the keynote speaker. Once again, thank you for your presentation today. We really hope to see you in person someday in the future. Thank you. Good morning.
Thank you very much. Thanks for the opportunity. Take care. Bye-bye.
Bye. And then, right. Before we welcome the second keynote speaker, I think the MC would like to introduce the second keynote speaker before we start. Time's yours.
Thank you so much, Professor Omer, for the insightful presentation, and Dr. Ari.
The second presentation will be discussing AI and cybersecurity, gaps, dead ends, and opportunities from Professor Yuki Katobayashi.
Professor Yuki Katobayashi has been leading the Laboratory for Cyber Resilience in Nara Institute of Science and Technology, Japan, where he works closely with research communities worldwide to further progress the state of cybersecurity. He also initiated cybersecurity education programs in academia as well as industry sectors in Japan, which resulted in a strong alumni network of more than 1,000 cybersecurity specialists.
While the industry benefited from the adoption of AI and machine learning in cybersecurity, a fresh new batch of academics are still left with decade-old dataset, which is essentially a shadow of the past. In order to avoid leading these brilliant minds to the dead end and irrelevance, what can be done? So, in this talk, we invite the audience to brainstorm on possible source of challenges, as well as a fresh new field which remains largely unaddressed by the community.
So, without further ado, I give the session to Dr.
Time is yours.
Thank you, Rai and sorry, after. Okay, let us welcome the second keynote speaker, Professor Yuki Katobayashi from the Nara Institute Science and Technology, Japan. He will be presenting the topic about AI and cybersecurity, gaps, dead ends, and the opportunities. Okay, are you online? Yep.
Yes, can you hear me?
Yeah, I can hear you clearly, Professor. Okay,
great. So can I share my screen so that I can project my PowerPoint?
Yeah, it's already on, Professor.
I think my screen sharing is disabled, so I'm wondering if I can. Oh, it's on screen projected.
It's already projected. Yeah, it's on.
Okay.
Yeah.
Then.
Yeah, we will have about 40 minutes, Professor, for the talk, and then 40 to 45 minutes, perhaps, and then we will continue with the question and answer session. Thank you.
Yeah, let me proceed. So, should I share screen on the Zoom or do I just have to keep talking?
Yes, I think. Zoom share screen.
Yeah, because Zoom sharing, screen sharing is disabled. I'm wondering if I can go ahead. Okay, so now it's working.
Professor, it's been moderated by our team, so
Okay.
yeah, I see you're already on. Yeah, yeah.
Yeah, now
Please.
hopefully you see my screen, and as well, if the slide deck is projected on
Yep.
the podium, maybe you
We
can
can
scroll
see the-
likewise.
We can
So,
see
so
the-
thanks for his introduction. So this is Yuki Kadobayashi. I work at the Nara Institute of Science and Technology, which is graduate school in Japan. And I've been working on cybersecurity and machine learning for more than 10 years. And I see a lot of trend as well as challenges and some problems. So in this conference, I'm trying to share with you what is the challenges and what kind of trend we have, what kind of common problem we have, what's opportunity, especially for young researchers and also for researchers who has been working in other fields, willing to work in cybersecurity domain or collaborate with cybersecurity researchers. So let me just begin by introducing myself. So I've been serving as editor for one of the top journal in this field. It's for competent security journal for more than 7 years. And the journal is now getting a lot of very good impact factor. Now it's 5.6. It's one of the top ranked journal among all those cybersecurity related journals. But I would like to say that many people are simply trying to bring in some of those existing technologies, existing like machine learning algorithms, deep learning algorithms, the existing data sets. And in many cases, these papers which tries to just tie together existing algorithms and existing data sets, resulting in marginal contribution. And in fact, we get a lot of submissions like this, and many of those submissions are rejected. So I'm here because I don't want those brain to be wasted, because many people are still, spending their precious time trying to come up with top-tier results by combining existing algorithms and existing data sets. But many of those attempts has been wasted because of this kind of, lack of enough guidance in terms of how to tackle cybersecurity problems. So I have been working on this machine learning and cybersecurity for more than 10 years, as I said. So I think this is very important problem. Some people doesn't like, machine learning or deep learning because of maybe somebody calls it voodoo or black art, black magic. But I see a lot of promise in this domain. But I would like to say there has been too little effort to solve hard problems. So many people tries to just readily combine those algorithms and data sets. But the hard part is more like working on new data sets, or working on reducing noise, working on labeling data sets, working on dealing with outliers, working on imbalance, or working on much new problems. So this actually requires a lot of legwork in addition to brain work. And many people try to come up with new results just with brain work, right? But here, in many cases, like as with other domain like natural language processing or robotics, the hard part is coming up with new problems, new data sets, new applications. There is a lot of effort involved in generating new data sets, preparing new environments, and reducing noise or denoising or labeling data sets. And this requires time. This requires a lot of effort. So I'd like to just say the hard problem is not straightforward application of theory. So this has been done. So if you ever think about new combination of theory and data sets, you should assume many of those brilliant minds came to those conclusions, similar conclusions, and worked on similar papers in the past. And many of those resulted in one of those top-tier conferences, top-tier journal papers. Can I keep going? Okay.
Yes, sure.
So second slide. So here, this is the gap. I mean, this is the problem we have today. So in the machine learning and cybersecurity, originally, if you are trying to come up with top tier results, you should do the gap analysis. For instance, what's the problem in autonomic driving? What's the problem in smart city, right? And come up with problem definition. For instance, what is cybersecurity problem in smart city? What is cybersecurity problem in autonomic driving? And this kind of problem definition is key. And there are so many important opportunities. For instance, think about, for instance, smart grid. Very few people are working on cybersecurity for smart grid. Very few people are working on cybersecurity for logistics. Very few people are working on cybersecurity for medicine, for instance. And we need a lot of brilliant minds, brilliant talents in these new applications of, for instance, machine learning algorithms to new cybersecurity problem. And here, maybe you have to prepare some experiment, and you must obtain some data. For instance, if you're working for cybersecurity for clinics, maybe you should prepare, work with doctors and do some experiments, or maybe you should seek some agreement from like patients. This is hard part, right? And in the end, for instance, by working with like 10 doctors, 500 patients, eventually you obtain data. So this is hard part. And then from these data sets, you can discover insight and you can report your findings. So discovering insight, this is, I think, easiest part. I think you apply many of those existing machine learning algorithms, and many, effective parameters has been published in previous papers. So you can almost copy and paste from existing TensorFlow, Keras, whatever, machine learning code, and apply those, open source library and known techniques to those data sets and report your findings. You got very good precision, like 99.9%. And here the data analytics are, maybe you can only spend 1 month on this, and with 1 month and enough experience, maybe with the supervisor's guidance, you can come up with very high precision result. And this kind of paper, if you went through those necessary legwork, and if you come up with new problems or new challenges, these papers will be accepted, because we are working on new problem. You did your own work in terms of legwork in addition to brain work, and this is top tier result, I would say. But many papers which we receive in the journal as well as the conference review process is on the right hand side. And here, in many cases, people just, for instance, if you just latch on the problem like intrusion detection, right? Because you work on cybersecurity, let's work on intrusion detection. So there is no significant deliberation here. So you just jump on its conclusion. Oh, that's intrusion detection. Let's work on intrusion detection, right? And there is no gap analysis. So maybe you don't know the operational reality of cybersecurity, and you don't know what's associated with intrusion detection, and what kind of problem you have with false negatives, false positives, and you think, oh, come up with new high precision intrusion detection, and this will be one with a good paper. Go ahead. So essentially, by doing that, by blindly reaching conclusion, for instance, working on intrusion detection, is that you are borrowing problem. Somebody has defined the problem in the past. Maybe you are looking at past publication, like there has been many papers on intrusion detection early in like 2000 to 2010, and looking at those papers, oh, let's work on intrusion detection, right? And here there is no gap analysis. Even if you work on intrusion detection, if you really work with top-tier cybersecurity experts, there is much more modern problems regarding intrusion detection. But you don't even talk to those top-tier cybersecurity experts who is dealing with fighting with ransomware, cybercrime, etc. from day to day. And if you don't talk to them, you just arrival into detection, which is classic old problem, which has been existing for more than 10, 20 years, and you know, you don't do any experiment. In the extreme and worst example, I arrived at many paper submissions which just used data sets from like 2000, which is like more than 20 years ago, right? So data set from 1990s or 2000, like KDD cup data sets. And this data set has been around for more than 20 years, and we still get submissions like this. Submissions using more than 20 years of data sets, pretty old. And you know, there's been a lot of work done in the past because this data set existed since 1990s, and many people, brilliant people, worked on that. So indeed, there is paper, but you know, looking at the paper, you know, pointing at the paper from classic or 1990s, and you say, oh, we can make a result based on this. It's not going to be the case because the cybersecurity field is rapidly evolving, and the nature of the problem is very different from what used to be in 1990s or early 2000. Now we are living in 2023, and there are a lot of problems which is awaiting to be solved in 2023, which is not just malware, which is not just a smartphone, right? So we have a lot of problems, like for instance, IoT. There's been a lot of innovations in IoT space. And what about smart cars? What about drones? What about radio communications, 4G, 5G, you know? So there's a lot of innovations done elsewhere, which got reflected in cybersecurity problems. And we need to work on much newer data sets, even if you work on existing data sets. And we should also deal with multiple data sets. There are so many innovations in terms of data set space. There's been some risk scholars who has been working on creating data sets because the KDD cup data set has been a problem. It has been prevalent problem. So there has been some researchers in Canada, for instance, they came up with creating new data sets by their own effort, published papers. And so in the modern work, you have to wrestle with multiple data sets from multiple sources. That improves more credibility of your work, right? So even if you borrow data, it should be multiple. And if you just borrow a single data set from 1990s, it's going to be dead end, right? And in the dataset analytics, for instance, there is also some problems, like you just compare results. You compare results with previous work, and in comparison with previous work, this work has much higher precision, etc. Right? And you brought some numbers like 99.97. It's much better than previous work. But this kind of work gets rejected. I mean, this is, I would say, waste of time. So instead, you should, start talking with some stakeholders and, think about problem definitions and think about arriving at a new problem, right? So KDD cup dataset, that's what I mentioned. It's decades old, and you may arrive on new theory. But for instance, if you deep learning and machine learning theorist, you may see, for instance, few-shot learning. Few-shot learning, it's one of the wildest ideas in these days. Let's work on that. But this has been done already. So there is a very good paper on few-shot learning, deep learning, etc. malware analysis, and the federated learning even. It's also well studied, well addressed federated learning for cybersecurity. Yeah, and even if you're very good at mathematics and optimization theory, you might be interested in like ant swarm optimization, cat swarm optimization, eagle optimization. There's a lot of buzzwords associated with modern innovations in optimization theory. But again, this has been fairly well studied in the domain of cybersecurity, right? So even if you have some pet theory, just applying pet theory to cybersecurity problem doesn't make up new journal paper, right? because in many cases you get only minor improvements. Because for instance, with deep learning alone, like CNN, or even with K-nearest neighbor, much classic theory, in some cases you can arrive with very high precision, like 99.9%, right? 3 nines, 4 nines, 5 nines. So it's been done before. So in terms of precision, you cannot get even modest improvements, right? So at the best you get the modest results, because previous studies has done a lot in terms of precision, right? So the question is not precision any longer. Maybe you can work on explainability, you can work on data imbalance, you can work on new set of challenges other than precision. Otherwise your paper will be buried among all those existing papers, right? Yeah, and we get a lot of submission like this. I mean, compared with, for instance, CNN or KNN, we got some minor improvements, 0.002% improvement, something on single data set. Is this plausible? So many of these submissions has been wasted, and we rejected, and there is no visibility in the rejected paper. So there are many proceed forward, and we cannot give any guidance regarding how to better deal with this problem domain. We just reject it or go forward, right? So here I would like to give you some hints regarding how to better address this opportunity. I mean, the AI and cybersecurity, I think this is huge opportunity, but many people are missing a very good opportunity because of many, I don't know, lack of guidance, or lack of insight, or lack of experience, or lack of professional network, I don't know. But here you can, the key thing is you can keep striving, try to solve the new problem, try to arrive at new problem definitions, or try to arrive at new combinations of techniques and the problem domain and solutions. So in order to do that, I think the best way is talk to industry, because industry has lots of problems. Industry now has a problem, for instance, there is a problem with JavaScript. Now it's mighty, and for instance, there is something new beast called WebAssembly, right? Maybe you haven't even heard of WebAssembly, but it's everywhere. All of your browser now supports WebAssembly. So what about security of WebAssembly? Very few people worked on that, right? And now people are wrestling with those JavaScript problems, WebAssembly problems, or even Microsoft Excel or Microsoft Word. There's a lot of malicious attachments, right? And they have problems, and they have a lot of agony associated with, for instance, analyzing those Excel macro or JavaScript, because there can be malicious JavaScript and benign JavaScript. The hard part is how to tell the malicious JavaScript from benign JavaScript. It's a very hard problem, and for WebAssembly it's even harder because it's compiled, and you can still reverse engineer WebAssembly code, but it's actually tied with JavaScript. There is some interactions between browser JavaScript and WebAssembly and remote website. So it's very tangled problem. And for malicious attachments like Microsoft Word attachments, it's also evolving almost every week. There's a huge campaign going on. For instance, emotet malware has been agonizing every major industry, but not many work has been done in terms of detecting and analyzing those emotet malware, for instance, right? So working with the industry, this is very important, but in many cases they want to keep it secret. They don't want to disclose data set. For instance, we worked on car security. We actually analyzed, connected to the ODB2 port in the cars, like Subaru cars and Suzuki and those Japanese automotive cars. And we extracted data sets, and we did deep learning analysis, and even we published papers on that. But we cannot disclose data sets on those Suzuki or Subaru cars because we didn't have any agreements with those car manufacturers. We took data sets from our own cars or cars we had access to, right? So there is a confidentiality problem, but still you can publish results. And we get a lot of inquiries regarding, can you give me those Subaru, Suzuki data sets? We cannot. Because we work with industry, we work with real world problems, and how can we disclose these data sets? Right? It's impossible. Right? But still we get a lot of insights regarding how Subaru, Suzuki cars assign Kennedy and how those systems interconnect, interact, etc., etc. Yeah, and for instance, we can also work with industry who is organized with ransomware or who is organized with targeted attacks. We get some memory samples from those victimized enterprises, but we cannot publish those memory because it contains passwords. It contains a lot of enterprise activity, but analyzing that gives us a lot of insight into how the malicious parties actually works within enterprises and how they sneak into the enterprise, how they do data movement, etc. But we cannot disclose data sets. We can only get insights and reports insights to papers. But people are actually sitting back and say, hey, can somebody give us some targeted attack data sets? Nobody will, because of the confidentiality. Everybody has confidentiality in terms of what kind of application is used, what kind of username, email address, etc. So there's a lot of privacy and confidentiality issues associated. So we cannot disclose any of those data sets, even though we have worked on forensics, we have helped to fight against ransomware crime, etc., etc. Yeah. So the key is to get your hand dirty and work with the industry, and they will strap you with non-disclosure agreement. But you should live with it. Non-disclosure agreement is part of the cybersecurity research, right? And then you have to work on emerging field, like for instance, look at blockchain. Can you actually work on blockchain security? There's a lot of innovations here, like security of smart contract. It's one of a very big topic. And what about the cloud? For instance, zero trust security. That's another very important opportunity. Have you ever worked on zero trust? Or there's a lot of details associated with Azure, GCP, and AWS. They have their own security model and they have their own security controls, guard duty, sentinel, etc. So there's a lot of specificity, and you have to dig deep and deal with those specificities. For instance, study details on how Microsoft Cloud works, how Google Cloud works, how Amazon Cloud works, and get those like for instance activity logs or API call logs or memory dumps. I don't know. There's a lot of details, right? And IoT, it's another huge possibility. Everything is IoT. What about smartwatch? What about printers? Even printers are very good IoT devices today. Everybody ignores printers, but printers are major target of hacking. And the routers, for instance, Cisco routers, Juniper routers, etc. They are also hacked almost every week. How to defend those routers? And what about smart grid? What about the PV panel out there? What about other aspects like energy exchange? There is a web portal for energy exchange, energy marketing, right? And for smart cars like autonomic vehicle, even the lidars, sensors. There's a lot of attacks against lidar, GPS, and subsystems within smart cars and autonomic vehicles. Or what about smart agriculture? What about security of LoRaWAN? Long-range wireless access network. So, if you think about those new emerging topics, I'm not nominating, for instance, 5G. It's another big topic, and 6G it's gonna be even bigger topic, and very few people are working. That means that's a huge opportunity for many of you, right? And the key is to work on harder problems, define new kind of problems, right? like security for WebAssembly, or that's huge new problem. You can work on security for WebAssembly. You can still find some web-based literatures, but there will be almost zero reliable publications on detecting WebAssembly malware, right? And detecting nothing is opportunity instead of being risk. In some cases, people complain, I cannot find any previous papers, so I don't study. But it's inverse. Actually, if you didn't find any similar papers, that means opportunity for you guys, especially for young guys. And then you should also come up with data set, right? Necessary legwork, and you should work with experts. In some cases, electronics engineers. In some cases, it's gonna be subject domain experts like medical, doctor, or it can be factory owner. It can be stock market owner. I don't know, smart grid exchange owner. So there is a lot of problem and challenges associated with new data sets, acquiring new data sets. And maybe there can be new non-disclosure agreement, or there should be some partnership agreement, etc. But once you do that, you get a lot of new problems, new challenges, new opportunities, right? And here, if you get new problems, new data sets, there is no double, right? You get, for instance, telemetry from smart cars, and you don't have any label on it. What about PV? The PV energy smart grid energy unit, and they have a lot of telemetry, but there is no label associated with it, right? And you should start doing that. And then even if you work with synthetic data, you should come up with plausible synthetic data, like likely attacks against PV panel, likely attacks against automotive systems. You should inject those artificial attacks and label as such. And if you have some data sets coming from real cars, in some cases you need some denoising, or you need some kind of data sets cleansing. Maybe there may be some missing fields, there may be something which is not aligned with a particular column, etc. There's a lot of data set denoising and data set cleansing necessary. And this requires time, and people actually respect this kind of activity. I mean, coming up with new problems, new data sets, and new devices, or even new thinking, right? Maybe even you don't have to, work for better precision, because a lot of work has been done on precision, right? Instead, you can focus on explainability. Or instead, you can focus on dataset imbalance. You can focus on bias, right? And so regarding gap analysis, you should also look at many papers. Of course, you can also ignore papers and do some brainstorming. But if you start asking, for instance, industry, what's going wrong? What they are wasting time. For instance, security analysts, they are just spending 24/7, almost day and night, fighting with malware or JavaScript programs, driver download, email attachments. So you can ask them what needs to be automated. What is the most time-consuming part, right? And you can analyze, what's not covered in the existing papers, because if you talk with industry, what industry says, and we can also, compare and contrast what industry is saying versus what academics has been delivering, right? Or what product has been delivering, right? In many cases, products are delivering something to screen, right? IDS alerts generated on screen. And who is going to be dealing with these IDS alerts on screen? Human beings, right? And think about 2 or 3 systems. You have web application firewalls, anti-intrusion detection systems, and you have DLP appliance, email security gateway, etc. Each of them have web-based alerts, right? Think about analyst operators who has to operate with 4 or 5 web-based alerts on screen, right? It's gonna be agonizing, right? You get a lot of alert from device A, device B, and device C, and device D, right? And yeah, so that kind of problem still, exists in the industry, and even with SIM, I mean, there is a device to aggregate those alerts. You have some difficulties. Maybe you have your own unique set of combinations of devices. Yeah. So this kind of gap analysis and problem definitions requires domain expertise. If you are just exploiting in terms of machine learning theory, you may not have domain expertise in terms of security controls and the programs and cyber threats and etc. So the key is to work with cybersecurity experts, right? So they have their own needs, and they have their own busy days being spent on triaging alerts and dealing with lots of warning email, lots of web-based alerts, etc. Yeah, so talk to them, analyze their needs, and see what you can do, and this will be very good starter to your research. Okay, so this is one of the gap analysis. So we did some anti-phishing study. We delivered a lot of paper in terms of how to deal with phishing. And here, if you observe the trajectory of the eyes, this is eye tracking device on top of the display, and if you measure the behavior of novice versus experts, novices are looking at everywhere, like graphical elements, and make trustworthiness judgments based on beauty of graphics. Oh, this looks like authentic. I trust these websites. Whereas experts only look at address bar, and if it's TLS or not, padlock icon, etc., and they make trustworthiness decision, right? So we measured this by the eye tracking device, which was a huge investment back then. It's documented in this paper in 2014. And more recently, we came up with a much handier device, which is a smart glass. And we measured the vigilance of each of those users. And likewise, this was phishing test, right? Fictitious phishing sites on benign sites, and judge if they can actually survive through a series of phishing and benign websites on smartphone screen, right? And we actually found that even experts can be can fall prey of the phishing if they are not vigilant enough, right? Because this smart glass actually measures level of vigilance, and vigilance is key to protection. This is what we found. So in the day-to-day business, for instance, are you measuring vigilance of your workers? So this is a key question, right? We just say, oh, just be aware of, just be careful to the malicious attachments, malicious websites. We can keep saying that, but if you have devices like that, smart glass which can measure vigilance, then you can actually block them from visiting those random websites if he or she is not enough vigilant, right? Right. So when you're defining your own problem, you can look at a lot of threats, different threats. For instance, many people tries to deal with malware or denial service, right? These are two topics, like malware and DDoS. These are common topics in paper submissions. But what about others, like rogue applications? There's a lot of smartphone application submissions every week to Google Play and Apple, smartphone market ecosystem. But what about those rogue app detection? What about those malicious application detection? What about rogue radio? Right? There's a lot of radio signals emitted nearby, and there's car theft going on almost every week, and how to detect them, right? And the target can be many things like smartphone, PC. These are classics. But about IoT, IoT doesn't have any antivirus inside, right? You cannot install anything within those commercial IoT devices. And what about smart car? What about smart city? And think about the control. You have browser, in addition to modern devices like endpoint detection and response. This is much more high precision control than antivirus. EDR is much precise. And SDN, software-defined network, this can be effective defense against network-based attacks. And then you have your favorite classics like IDS, intrusion detection system. But if all these fails, you may have some operational, human-based response against those problems, right? So these are the hints to defining your own problem. So you don't have to, work with malware. You don't have to work with DDoS, right? Look elsewhere. You don't have to, deal with those very difficult PC-based malware. You have much easier ones like IoT or smart city. So I can give you some examples we did. For instance, this is the car security work. So like I said, we extract data set from Japanese car models, and we did deep learning based, detection system, anomaly detection system, very high precision. Yeah. And this is another example. So here we worked on the airport security because the radio signal called ADS-B, which is prevalent in airport operation, this can be easily spoofed, right? And this student from Malaysia actually worked on airport security, and there can be some ghost aircraft, like spoofing ghost aircraft, which doesn't exist, but it's spoofed because of the radio signal. And we can detect this radio spoofing. It's spoofing detection. And operationally, we respond to this kind of ghost aircraft incident. And that's what we did, right? We do radio check, and also if we cannot validate the trustworthiness of those ghost aircraft, we actually, modify operation, and there is some contingency plan, etc. So that's a new problem in cybersecurity, right? And also for the data acquisition and experiment, in some cases you don't have to do the very expensive legwork. In some cases you can deal with open source tooling or some cloud-based technology like container virtualization, and in some cases you can deal with a synthetic workload. So this is another example. We actually acquired data set from KVM and the QEMU, which is one of the well-known virtualization system, and you can incorporate telemetry inside this kind of hypervisor and get process API call and system call, etc., from which we can do anomaly detection, right? And this is another example. So here we actually did further introspection, further instrumentation on the QM KVM, and we actually found malicious behavior like opening device, opening file, etc. Right? And we actually did almost automatic analysis of IoT malware, and we demonstrated that this kind of cloud-based, virtual machine-based sandbox is effective to massively analyze IoT malware. We actually demonstrated, for instance, phylogeny, classification of lot of IoT malware, for instance. Yeah. And then there is some work on reporting insight. In many cases, if you are trapped in the machine learning thinking, you can easily think about the confusion matrix, precision recall, F1 measure, rock curve, etc. But instead, you can, arrive on very simple thing like bar chart, right? For instance, this is one of the insights we got from a comparative study among Japan and Tanzania, because Tanzania, we got student from Tanzania, and he said the cybersecurity in Tanzania is lagging behind. So we did some comparative study. Who is responsible for data breach? Right? Very simple question. And most people in Tanzania responded, oh, it's maybe service provider problem. Look at this black one in the bar chart. Service provider problem. Many people in Tanzania responded, I don't know, or it's telco problem, right? And in Japan, in contract, many people said, "Oh, data breach is my problem," right? So this, illustrates the huge gap. I mean, I would say this is digital divide evident in cybersecurity domain, and this has to be somehow eliminated. I mean, if those people in Tanzania is well educated, they will also, sense the self-responsibility and self-esteem in cybersecurity and privacy. And for instance, for much complex topics like targeted attacks, there's a lot of large-scale measurements done in U.S. and elsewhere, and they came up with more than 1 year of data sets, more than 2 years of data sets, and they analyzed those targeted attacks, and they said, targeted attacks are actually happening across these 15 techniques. You have a lot of techniques, more than 100 techniques to do cyber attack, but they said the most simplest one, like command line scripting and scheduled tasks, these are most prevalent technique, right? So this kind of insight is helpful to bring the defense forward, right? So this is actually openly available. So that concludes my my quick talk, and here we addressed AI and cybersecurity. And like I said, there is too little effort to solve hard problems, and too little legwork, right? So we should do legwork in addition to brain work. That's something I said. And if you are experts in robotics or NLP, or autonomic driving, or sensing, or any kind of engineering, then you may have your own data sets, or you may have your own problems, and these problems and data sets are going to be very important. That will be highly valued in cybersecurity domain. So there is a fair amount of opportunities that people in other domain can deal with cybersecurity experts and come up with very good results, right? And I also talk about the importance of working with industry and working emerging field like blockchain, cloud, etc., and the importance of working on hard problems, and the importance of work for others. Because if you come up with those data sets and those new problems, then all the computer science and all the people defending many kinds of diverse infrastructure will benefit. So essentially, that's my talk, and I hope I get a lot of insightful feedbacks and discussions from our audience. Thank you.
Thank you very much, Professor Yuki Karubayashi, for your sharing the knowledge, that you have researched throughout the years. For your information, Professor Yuki Karubayashi, we visited Nara Institute of Science and Technology last year. It was a big group, 14 of us, and then we were very welcomed by the staff in there. And finally, we can follow up the visit by inviting you in this conference. Right. Now, let us open for the question and answer session for the second keynote speaker. Please, anyone, if you would like to know deeper about the AI in cybersecurity, you can raise your hand, or you can use the Zoom platform to ask questions. Right. Now, I will start collecting the question from the audience. Please, anyone? Yeah. Anyone from the Zoom meeting? Okay, I will start the question, Professor. There are 3 questions that I need to raise. The first question is, it is about the AI against the native algorithms, the machine learning algorithms. How is the AI for cybersecurity perform? How AI for cybersecurity perform against the traditional machine learning in terms of the performance in handling the attacks? That is the first question. And then the second question will be AI, the implementation of AI has raised another issue, that is the privacy of the users. How is the ethical aspect to be considered in implementing AI for cybersecurity? And then the third question is, as you mentioned in the presentation before, that KDD cap dataset is an old one, it's decades old. And then, while the cybersecurity always evolve, how can we get the AI algorithms to learn about the new kinds of threats? I think those three questions that I need to bring up in this occasion.
Okay.
Yep.
Yeah. So the third way is, I think AI is actually must have. I mean, because the network is becoming faster.
Yeah.
Right. So you cannot keep up with 10 gigabits network in order to defend network in real time by human beings alone. So here, machine-based assistance is essential to defend network against any kind of emerging threat. That's why we have been working on machine learning and cybersecurity for many years.
Yeah.
We foresee this is happening, this is coming, this is necessary. Otherwise, we cannot defend it because the network today is 100 gigabit, and also the machines are becoming much smaller, like smartwatch, right? Or like even TV has something like Linux, or a printer has a Linux, and our like camera may have Linux, and every system is getting more and more intelligent. And if you look around in a building, likely that you have more than 100 devices. How can you correctly configure it? It's impossible. So I think machine-based defense is necessary. So that's why we have been working on AI for cybersecurity since very early days. We thought this is necessary. In early days, where people were only working on computer vision and speech recognition using machine learning, and for ethics things, I think that's one of the very good important point. And we also work on privacy. For instance, in our laboratory, we work on privacy techniques like differential privacy. We also work on techniques like confidential computing. So these privacy engineering techniques are another, I think that it's another domain, a neighboring domain. And in our laboratory, we cover both. I mean, defending systems against nefarious threats, as well as defending against privacy leaks, and protecting people's information. So these are relevant techniques, and I think it's important to keep an eye on both security and privacy, because it's balancing act. If you work on privacy alone, then you will enemy security people by, for instance, encrypting everything, right? So encrypting everything is, like, I would say, it's silly defense, because you can defend privacy, but you have no vigilance against what's happening inside, right? So there is a lot of activities going on, like encrypting DNS, encrypting email, encrypting HTTP, and now everything on the network is being encrypted. As a end result, we don't have any network level visibility into what's going wrong. So even if you have some bot networking behind, you cannot detect it network level because everything is encrypted. Now it's happening. So that's one of the
categories in our class integration. So this categories not only work for automatic but also for the steganography. And the data hiding can work as in this diagram that we have a carrier or a cover. Then we also have a secret or payload, the data that we would like to protect. For example, the data can be represented in binary, like 1, 1, 0, 1, 1, and so on. Then it is put inside the carrier of the cover data. It's just manifestation, and we have the stego data. This stego is then sent or transmitted to the receiver through any medium like computer net or maybe the internet, and it is received by the receiver or the destination. Next, the receiver should extract it. In the case that the receiver can extract the payload only, then this method is called irreversible. But if the receiver can extract both secret or payload and the carrier on the cover, the method is falling into reversible data hiding or RDH. Which one is better whether we use the irreversible or reversible? Usually it depends on the purpose of the protection. So we cannot say that reversible or irreversible is better than the others because as we said before, that it depends on the purpose of this protection mechanism. The medium that we can use, for example here, there are various medium that we can use to carry or to accommodate the secret data. For example, like image and also video, audio, or even the text. And all of them can be classified into two categories. Either in the transform or in the spatial domain. The spatial domain is that we can directly identify by the transform. We need to transform it into a signal by using transformation algorithm. To give the illustration how the data hiding, I think it is better if we can see a simple example of this method. You can use an image as an example here. We can show a simple example on this. For example, here we have an image like this. And we open it by using a viewer. Let's just come the image like this. And we open it by using editor. For example, we can use Notepad. We just see that there is an unreadable character as in this file. You can see until the end of this file. We find that in the last line is 4,736. Just like this is the last line. And we have an example of the payload from the secret that we would like to protect in this. Yes. Oh, belum ya. Baik. Sorry, I haven't shared screen. Okay, let me repeat again. For example, we have an image file. If we open it by using viewer, it just comes an image like this. You can see it now. And we open it using text editor, for example, using Notepad. That is the text that we would like to protect and we put in this image. In this case, we put the text as ICTS 2023 and there is a line of that. We would like to put this into this cover by using a simple command in the Windows operating system. We can just use a simple example here. By using the copy command line, copy cover is taken from this cover image, and then followed by the slash plus it is for the option, and text we put this message into this cover, and the result will be in the stick.cpap. If we enter this, then we have a new file here like this, and we compare. This is the original one, the original cover. So. And this is the stick file that already contains the secret message. Can anyone differentiate between those two images? Is there any difference between those two? There is no difference. Okay, if we open this using Notepad,
And we
would like to see is there any message inside that.
We go
to the last line.
We remember that in the original there is no message inside that. What happened? Check it again. It is already there. ICTS 2023 So it is a simple example how we can put the hidden or the protected data into the image. It is simple because we can just use Windows command line. But because of this simplicity, of course, the security is not good. Security is not enough. Everyone can detect it. I think it is not too difficult to detect the existence of this protected data. So to get more sure, we need to develop an algorithm that can hide the data properly so it cannot be detected by the attacker. Back to this. Interesting here, we already developed some algorithms and we use some parameters to evaluate whether the algorithm is good or not good for this case. The first parameter can be used to evaluate the method is the capacity. Capacity means that the number of bits that we can put in the medium. For example, here we have one binary text. This represents the capacity of the payload. So if we have more bit that we can put into our accommodate by the image, it will be better. And the second parameter is the quality. The quality can be measured by comparing the stick code and the original cover or carrier. If the stick code is more similar to the cover, it means that the stick code is better because there is no difference that can be detected by the attacker easily. However, if there are noises here, so the stick code can be detected by eyes by the attacker. The attacker might think that there is something inside the stick code data, and they can suspicious and can be broken by the attacker. That the quality can be measured by using the PSNR. It means the similarity when the capacity can be measured by using the number of bits or maybe it is in the case that the cover is the image bit per pixel or maybe bit per block per pixel. The third parameter is the reversibility, which means that whether the stick data can be extracted to put the payload and also the cover. If the payload and the cover can be extracted fully, it means that they can exactly extracted. So it can be used for the other purpose. But we cannot say that irreversible in the previous slide. Irreversible or reversible depend on the purpose itself. The fourth parameter is the complexity. It means that how complex to put or to get the payload to the cover to get the stick data. The complex algorithms only means that the attacker can get more difficulty to attack. However, it takes time to put this payload to the cover. So there is a threat of the Windows laptops. And the next parameter is the robustness, as we already discussed before, whether the stick data can still be extracted to get the secret and the cover in case the stick data is modified. Either it is intentional or unintentional, for example, by compressing, maybe by rotating and some other action to the stick data. Some example of the RTS or data hiding can be illustrated. In the previous example, you see that we can use the command line in the operating system of Windows. But it is not good enough in terms of security. This is an example of the development of the algorithm in the image-based RTH by taking an image as cover. For example, here we have an image, then we divide it into some block depending on the size of the pixel. For example, in this case, we have one block consisting of 4 or 2 pixels. We have here is 2 pixels, we see here is 4 pixels. And then we calculate the difference between those pixels. And we put the secret or the secret data inside this different. So it is not in the pixel itself, but we put it in the different between those pixels. It is relatively harder to break by the attacker because they cannot take the pixel one by one and then extract it separately. They must take or they must know the number of the block size of the pixel that they use to hidden data. One of the algorithms that we already work here can be illustrated here. In the left side we have the emitting method, and in the right side we have the extracting method. In this algorithm, we limit the range of the different between -2 and +2. So the difference represented by P must be between -2 and +2. For example, we have one block, 181 and 180, depending on the pixel. Then we calculate their difference by using this simple equation. The first pixel value is subtracted by the second one, and F for example here is 1. The different value is 1. Next we put this we use this difference to hide the data. P represents the secret bit, so one bit only that we can put in the different those two pixels. P for example here is is 1. Is added to the different is G. It is G or P is actually is the same. We put or embed the data, D prime or V prime here is 1. 1 is taken from the difference between the 2 pixels in the block, and 1 here actually is the secret bit. So D prime or here represented as V prime actually is the same. Has value of 2. Next we calculate the new pixel value by using this equation. UI prime, UI means the pixel, neighboring pixel, and U1 prime is the pixel, U1 is the old pixel, while V prime or D prime is the embedded difference, and so on. And this process will be done in the reverse in the extracting process. As an variation on this method, we can use a single or multi-layer embedding. Single layer means that only one time iteration that we can implement it in the image or in the cover. Once we reach the end of the image here or in the last block, so it is done. No matter whether the payload or the secret bit is still there. Alternatively, we can also implement a multi-layer. It means that we can use the same cover on the same image, multiple or several times more than one embedding implementation. For example, it can be used to accommodate just in case the number of the payload or the secret data that we need to protect is quite big. So we can implement it in the same image multiple times. And also in the variation of this method by using whether the block is overlap or non-overlap. For example, here we only use one pixel, one block here. And
And then the second block is
here.
here. It is also possible that the second block is not
here,
but we can put it between these two. So it will be an overlap block. It is still possible to get an extension of the secret or the domain to extend the capacity.
Example, how the effect of the embedding. In this case, we use two types of the image. The first is the medical, and the second is what we call as a common image. Medical image, which characteristic is that it is gray level, and also actually the same as the second, the common image here. And we obtain the PSNR value is more than 50 decibel. The standard is 30 decibel at least. So if we have here more than 30, it can be categorized as it is implementable, or maybe we can develop to increase the quality. However, we see that here the computational time is relatively high, because we see here that the time that taken to embed the data is more than 3 seconds. It is relatively high. So this time should be reduced further. The second approach is to hide the data, or the secret data, into a video file. The previous one is in the image. This method, the second method, is to hide it in the video. The existing method is used what we call as prediction error, which consists of the difference between those frames in the video. Between those two frames, like in this frame 1 and this frame 2, we can calculate the prediction error. Between this frame 3 and frame 4, we have one prediction error. This method works well. However, there is a limitation in the number of prediction error, because we see here, if we have, for example, 1, 2, 3, 4, 5, 6, there are 6 frame, we only have 3 prediction error. So there is a limitation in the capacity. In the next development, there is an increase in the number of capacity by taking every 3 frame, and we can have 2 prediction error. And in the further development in our algorithm, we can have n-1 prediction error for n frames, like this. So every frame, in the between frames, we can use the prediction error to calculate the embedding capacity. This is for the development of the algorithm in the video-based RDH. We have a video file, and then we generating frame. Actually, frame consists of like an image, so we can divide the video into some frames. Then we generate PE, or prediction error here, like this. It is prediction error, and generating the histogram. So we analyze the histogram, whether we can put the payload on the secret data fully or not in this video file. For this purpose, we need to find the peak and 0 point to define the direction of the shifting, because we need to shift the histogram, whether we can put it to reach the 0 or in the peak point here, and so on until we have the deco and the win from this secret data. This is an illustration how we can calculate the prediction error and the respective histogram. For example, like this. We have frame 1 and frame 2 in the video. Then we will calculate the difference between those 2 frames by using the simple subtraction. 1 minus 9 is minus 8, 2 minus 8 is minus 6, and so on. And we put it in the histogram. This is a histogram of the PE, or prediction error, and this is the histogram of the frame 2 only. Next, we can shift the histogram according to the specified algorithm. In this case, we can go to the end of the 0 and the peak histogram here.
And for the result, we can put it, or we can take it from here. We find that what we have estimated, that by increasing the number of the size of the payload, we can find that the quality will drop, even it is not to significantly fall, because by embedding 1 kilobit, we can obtain 85 decibel. By embedding 10 kilobit, we can take 80 decibel, and so on until hiding or putting 100 kilobit, we have 71 decibel. So there is a trend to reduce the quality when we increase the payload size. The third approach is to implement the data hiding in the audio. In this case, we use the interpolation. The purpose is to extend the number of the space, the domain space, so we can put the protected file more bigger. However, if we extend like this, we can see the illustration here, there will be double of the file that we obtain in the final sticker file. The left side is the audio sample after we sampling the signal. For example, like that. So we discretize the continuous signal, and here we see the interpolated sample. We interpolated it to extend or to make it a bigger domain space. So the domain to accommodate the hidden file will be bigger. And this third graph is we obtain after we embed the secret data. We can compare between this graph and the previous graph here. We see that it is smoother than this. And because of this, there is a noise. So if we play this audio, we will get unclear sound here. To minimize this effect, then we can make it smoother by using a smoothing algorithm. We can compare this. This is after embedding but before smoothing, and the last one is after embedding after smoothing. We can compare these two graphs. If we see these two, then we can find that this after embedding after smoothing is closer than this after embedding before smoothing if we compare it to this interpolated sample. But we see here that this signal is still not the same as the previous one before we embed the protected data. So there is still noise there. To evaluate this method, we take a public data set taken from IRMA's dataset for instrument consists of 15. So we only take 15 audio file with various genre and instrument here. Like this, country folk, classical, pop rock, cello, and we find, as we estimate, that there is a trade-off between the capacity or the number of the payload and the quality. The first graph here represents the maximum capacity in kilobit, while the second graph is the quality. So if we compare the highest capacity, number 3 here, taken from the pop rock or cello, it will have the lowest quality, and vice versa, also for the other result. Which one is better depends on the purpose of the the purpose or the implementation of this method, whether we focus on the capacity or on the quality of the sticker data. This is for the development of the method. We make it in a different some modules here. From the latest development, we get a slightly different result. We compare here, but we still use the same data to evaluate the method using the same audio file. We have 15 audio file with same genre and instrument. When we compare here, we find that, for example, we make it in the second graph. that the highest is obtained by the classical genre, and also for the next highest PSNR value. For example, we have number audio number 2, number 5, number 8, number 11. And we see in this audio file specification, we find it that it is classical, also number 5 also classical, number 8 also classical genre, number 11 also classical. We find that classical genre can be used to have the high PSNR value, so it has the better quality. However, if we see and we compare in the first graph here, it represents the capacity in the kilobit. We find that classical can only take a smaller or relatively small number of bits. For example, number 2 here, classical. It is better on the quality, but it is worse on the capacity. And also, the same trend happened to other file in the classical genre here. For the variation, we implement the Shamir secret sharing by using the scheme. We define key n, where key is less than n of the threshold file. If in the previous method we only have one stego file, by using this approach we can have more than one stego file. The purpose of this method or this approach is to make it more secure, because in order to extract the payload or to get the cover, the recipient or the extractor must be joined together at least k of them. K here is the number of minimum recipient or the extractor that must join together, while n is the defined number of the stego file here. For example, we can define the number of stego is 5, and if we define key is 3 here, it means that 3 out of 5 must be joined together to extract the payload. So not only one. It can also be implemented in the previous approach by set the key is 1 and n also 1. It's same as the previous because we only have one stego file. For this multiple stego, we find that the result overall has lower PSNR value than single stego. In this case, we only have like this 48. If we put the k is 3, k is 4, and k is 5, k is 6. They are almost the same, and there is no much difference. There is no much deviation between those two, between those key value. It means that this algorithm is stable, and we can implement it in either k is 3, 4, 5, or 6, or maybe also it can be implemented in the higher number of k. In the further development, we can testing by using different data set here. The first is the common, by using the common image, digital image, and the second is using the medical image. If we compare between those two data sets, we find that by using the medical image, we can obtain higher result. For example, here we can see for the result here by using the key is 4, the value of the PSNR is about 53 decibel. But for this common image, we only have less than 50 decibel. It happens because there is a different characteristic between those two datasets, between the medical image and the common image. Yeah. And for the further development, we also try to get or analyze this by using the static analysis. It works by analyzing the result and how we can detect the existence of the payload in the stego image. What we have in this result is that we can detect by using this and measure using the accuracy and true positive rate, false positive, and etc. For the accuracy, we can see here that it is what we have is actually is better, slightly better than the previous works. We can have about 79 accuracy, 79%. If we compare with the previous work, we can see that it is higher actually. It also works on the other data set by using this WO data set and also the Uniword data set. Okay. I think this is the last slide. If you would like to contact me, we can get a discussion by contacting me in this email, tohari@ifitscat, or by accessing this URL. Thank you. I give to.
Thank you very much, Professor Tori, for the insightful knowledge made. I will invite the audience to further go into the research topic. So if anyone have any questions regarding this topic, please raise your hands, or if there's some question in the chat room. So that question. Okay, two persons. I think Pulija first, and then you can go ahead afterwards. Three. Yeah. So Pulija first. Yeah.
Thank you, Prof. Tohari. That's very nice presentation. And even though my background is not from the security, I think that it's very interesting topic. My question is, since you use the carrier using like image or audio, etc., are there any consideration from the text we want to hide? For example, the size maybe or anything, so that it gives us a better stego image or stego audio result. I mean, for a consumer, we need to have we cannot differentiate between the original and the stego ones. Are there any considerations on the image, or the text we want to hide?
How much payload?
Yeah, to make sure that the quality of the stego is good.
Yeah.
Yeah.
Thank you. The payload size, you mean?
The trade-off between the payload and the quality of the image. Okay, that's one question.
Yeah.
Any other questions from?
Yeah, that's all. Thank you.
Thank you. Please, Professor Has.
Yeah, one of the metrics that we can use to evaluate the method is by measuring the payload size and the quality of the stego. Payload size, as we in the previous, payload size falls in this capacity. It can be represented in the number of bit or binary digit here. For example, we have binary digit here. And for the quality, we measure by using the PSNR to measure the quality, the similarity between the stego and the cover. For the evaluation in the experiment, the capacity, we define or we generate a data set. It consists of a random binary number starting from 1 kilobit to 100 kilobit. So we have 1 kilobit, 10 kilobit, 20, 30, and so on until 100 kilobit. And the experiment show us that increasing the capacity causes drop in the quality. It can be understood because the quality will be affected by the noise. Increasing the capacity, it means that we put much noise in the stego. Because there is much noise, then the difference between the carrier on the cover and the stego will be higher. It means that it will decrease the quality or the PSNR value. Does it answer the question?
Yeah. think we can further standard the question, but how much is the limit we want to push data into the stable image, the media? For example, you mentioned about BPS and L.
Yeah.
You mentioned about how much we can push the data.
Yes.
For example, minimum BPS and L is
The
80.
maximum, yeah. In the standard, we have 30 decibel. By having 30 decibel, we can assume that the image can be seen clearly, or anyone, or maybe the attacker cannot find the data inside easily. They must take much effort to extract or detect the data. And to get the maximum number of bits, how many bits that we can put in the cover maximum, it depends on the size of the image itself. Bigger cover means that we can also put many or more bits inside that. And in some experiment, we also measure the maximum number of that. And there are some factors that we can consider, whether we put the maximum or just maybe in the average of the payload size. Because of that quality measurement. So we can still keep the quality is not less than 30 decibel. How many bits that we can put without reducing much the quality of the stego file.
I hope that answers the question. Okay. Next question will be from that side. Please, introduce yourself before asking the question.
Yes. Assalamualaikum and good morning, Doctor. So my name is Muhammad Nur Salihin bin Malik Razwan from University of Technology Malaysia. So it is actually quite indeed a good sharing from your side. So as we know that stable approach is good or useful to many organizations, and there is actually lots of improvement have been made by your side based on your analysis on how to improve the quality of the medium that the data that we want to hide reside in. So I believe that this kind of stable approach may be considering both positive and negative side. So on the negative side, I believe that the attackers may use this kind of stable approach to hide certain malware, or maybe kind of launch an attacks by using the medium that you said just now. So my question is that is there any actions or any analysis on how to prevent this kind of stigma to exist by using this stable approach? Thank you.
Media plays into this research
Yes. Yes, thank you. That's a good question. So far, we don't consider the type of the hidden data, whether it is malware or not malware. Because as long as the data is in the binary, then we can put it in the medium, like in the image or in the audio, video, and so on. Maybe in the further or in the following research, we can also consider to detect whether it is malware or not malware, then the data put in the medium itself. Thank you for your suggestion. Yes, it is also an open research. Thank you for your suggestion.
Thank you from delegates from India and Malaysia. I went to Malaysia last year. Okay, one more question I think from yes. Someone pass on the microphone to the please. Yeah, please pass on the microphone to
My name is Bambang from the student of ICTS. I want to ask about how to find out how many layers we can hide from the one image. Maybe that's my question. Thank you.
Okay. Yeah. In the previous slide, we have discussed that we can use an image as a single or multi-layer. Single layer means that we also we only doing the embedding in one time iteration. By doing multiple, we can embed the data several times, it means more than one time. When we can consider to use multiple, it depends on the size of the payload. For example, if it is only one iteration and the payload is still there, not fully put in the cover, it means that we still remaining bit that we need to put or protect it in the cover. In that case, we need to do the multiple layer. Whether it is 2, 3, maybe 4 or so on, it depends on the size of the payload itself. Until all payload are put in the medium.
Right, thank you. I hope that answered the question. Next round, please. We still have some time. Just let think about 5 minutes. I would like any questions. Yeah, from the Zoom meeting, do you have any questions?
Oh, ini yang baru.
Yeah, I think there's no question from the Zoom meeting. But I have one question. Maybe this will be the last question in this session. Can you discuss the trade-off between the capacity for possible generating while maintaining the quality of the media? Yeah.
Yes. Because there is a trade-off between the capacity and the quality, so we need to follow the standard of the quality itself. For example, for the image, the standard is 30 decibel. So we need to keep the resulting sticker file to have more than 30 decibel. If the sticker file PSNR is less than 30, so we need to reduce of the payload size. And we need to do refinement or revision to the, because in that case the method doesn't work well.
Right, I think that would be all, Professor Khalid. Thank you for your fruitful insights from the research, that you have conducted with your research team. Yeah. Once again, thank you for the audience for the engagement of this presentation and discussion.
Section. So, ladies and gentlemen, that was the main event of today's conference.
Wow, it was very incredible. Once again, let us give a big applause to our main event. Okay, so it looks like, we feel a little bit kind of like sleepy. And again, I was looking at the audiences and I started to see a lot of people kind of like yawning a little bit. And why don't we just recharge a little bit, don't you think?
Let's go. So after this, we're gonna having some fun with all of you.
Sure.
By having
We're gonna have a pop quiz, ladies and gentlemen. And again, it's not actually a pop quiz without a rewards. So we came prepared, and we have a super limited merchandise from our lovely CyberDAS event. So yeah, let's just get started again. Because it looks like everybody, before they were just like, feeling sleepy, but now they're like, oh my God, I'm ready for this,
Okay. So the first question is, wait, before that, I would like to note that in order to answer my question, you need to raise your hand after I count to 3, okay? So the first question is, can anyone tell the audiences here, or me and Rod, what are the key takeaways or anything that you have learned from the first what are the key takeaways that you have studied from Professor Omar Efrana of Cardiff University? I will count down from 3,
3, 2, 1.
1. Okay.
Okay.
Nobody actually raised their hand.
Yeah, maybe we just need. Yeah, maybe we just need to wait a little bit. Maybe they're like nervous. Oh my God! Like I want to come forward, but I'm just like I'm scared, because like I'm so nervous seeing all of these experts, and I'm just like a student. So maybe they're like feeling nervous a little bit, but we just have to wait for a little bit, right?
Alrighty.
Okay.
You don't actually have to describe your key takeaways, but maybe some of you can share the opinion. How do you feel
Yeah.
here being in ICTS 2023?
Sure. That's right. And maybe you just come forward and say like something a little bit, maybe, oh my God, the event was really cool. I want to be a professor one day. That actually could be an answer to this particular question. And again, really, what's really important here, you can get the merchandise. This is a limited version. Again, I repeat, this is a limited version. You don't really want to miss this. It might look a little bit, kind of like regular in there, but there's actually something inside of that. So you don't really want to miss this. All right.
Okay, I'm going to take the merchandise.
Okay, let's just take one of our merchandise. So again, I'd like to repeat the question. It's actually really simple. So what do you think about the first keynote speaker? Again, the answer doesn't have to be very technical. You can just like, I'm so happy to be here. The food is good. The food is great. I can't wait to see the next event, whatever. Okay.
Maybe most of you are starving today. It's
Yeah.
time. But before that, we need to actually have this merchandise.
Yeah, for you. All right. So, well, since it looks like, everyone is nervous, why don't we just go ahead and choose random person? How about that?
Okay, that's actually pretty fun.
Okay. I'm going to come forward. I'm going to go to this stage. I'm going to choose one random person to just say, their thoughts, whatever they're thinking. Okay. It looks like that you're very excited. You've been looking at us for quite a long, so maybe you have like some thoughts related to the first keynote speaker, Professor Omer Efrana. Please.
Hello, my name is Adam. So I think the talk is nice since I gain new knowledge to bring back to Malaysia, I think. So I think that's all.
Thank you. What's your name again?
Huh?
What's your name again?
Adam Haikal.
Adam. Okay, everyone gives applause to Adam.
Very nice. So our delicious. Give it to
I almost forgot the gift. Okay, this is for you and for Malaysia. All right. Okay, Fear, continue.
Okay, so let's get jump into the second question. So the second question is, can anyone tell me what are the key takeaways from the second keynote speaker, Professor Yuki Kazuhayashi? I will count down from 3. I wish that somebody will volunteer to go.
Yeah, to come forward. Yeah, to go to the stage. And maybe that's correct. Maybe say, little stuff, little things. Okay, let's count from 3, right? So 3, 2, 1.
I guess everyone's starting here, right?
Yeah, that's correct. Actually, I heard little noises right in the corner.
Oh, really?
Maybe you could go there, and see what's up. Let's see what's going on. Cause like I heard like a lot of noises right there. Okay.
Yeah, I would like to know that inside this tote bag, there's actually something, but it is actually a surprise because we don't even know what is it inside. So I think the one with the black hijab. Would you please? Okay. What's your name?
Hello, my name is Lani, and the key takeaway from the Professor Yuki is really the end, the opportunities, and maybe
Okay, so that was for the second question. Now, here it comes, the last question from, and the question is exactly the same. So what are the key takeaways from, but this time for the third keynote speaker, Professor Tohari Ahmad. But I think it wouldn't be perfect if the question is answered from the students. So why don't we just ask randomly from the lecturers as a fellow lecturers to sort of like give, a little thoughts maybe on Professor Tohari presentations. So why don't you just go downstairs and, I don't know, like choose random lecturers this time. And I trust my algorithm here, random algorithm, data hiding. So my heart goes this way. I want to go that way, but I don't know, somehow my heart goes this way.
That's really suspicious.
Yeah, everyone is nervous right now. I can tell. Boo. Yeah. Oh no. Maybe the Burati.
Okay, thank you. What I got from what Professor Tohari has presented is that we can, it is not really my field, so I'm not quite very familiar with those, but what I got here is that we can hide some data using what we call steganography. So in case of security problem, we can make sure that those data is more secure than if we have the data open just like it usually is. That's all.
Thank you, Burati. Everyone, please give applause to Burati. Ladies and gentlemen, thank you. We will have a break session for 1 hour and 20 minutes, starting from 12:10 until 13:30. For those who have to take a prayer, we have a musala on the ground floor across this hall. When you reach the ground floor, walk straight by the campus corridor until you see a stage. The musala is right to that stage. Again, I repeat, for those who have to take a prayer, we have a musala on the ground floor. To reach the musala, first of all, you need to go to the ground floor and then walk straight by the campus corridor, and then you should see a stage, and the musala is right next to that stage.
We'll also provide lunch that is located at the North Plaza on the second floor. It is actually pretty simple, so to reach the lunch area, you can step out of this hall and turn left, and you should see the lunch area on the North Plaza. I repeat it once again, that to reach the lunch area from this building, go to the left and you shall see the lunch area on the left corner. And I want to emphasize that lecturers and authors are prioritized to have their lunch first.
Starting from 13:30, we will begin our next agenda, which is the parallel session. Parallel session is a session where the authors present their papers. The authors will be assigned to their corresponding rooms to give their presentations. All of the rooms are located on the ground floor, and for convenience, we already have our staff who will guide the authors and all participants to the corresponding room.
After the parallel sessions finish, we will have closing remarks of ICTS 2023 by the conference chair, Dr. Baskoro Adi. We kindly request that everyone be in the room 107 by 3:30 this afternoon, as the event will continue at that time. Thank you so much for listening. We're looking forward to seeing you again at 3:30. Thank you.
Thank you. Ladies and gentlemen, please stay on your seat. We forgot to mention that we need to take a photo together. So ladies and gentlemen, please stay back on your seat. Again, I repeat, ladies and gentlemen, please stay back on your seat because we're going to have a photo session together. Would like to apologize for that. So maybe for the documentation staff, please come forward to proceed the photo section process. I invite all participants to stand up for a photo session. Gimana saya? Oh, kita di belakang kayaknya.
Baik. Nanti abah-abah ya.
Okay. Yeah. Okay, it looks like everyone is ready. So in 3, 2, 1. Once again, in 3, 2, 1. Okay, thank you. Ladies and gentlemen, now you can go and have a break session. Thank you.